The vast, scary nothingness of space. Why space has no sound. Did you know there's a vast and scary nothingness above our heads? The space is a huge void. It doesn't have any sound, but we need it to exist. What does nothing even mean? When most of us imagine the word nothing, we picture a space completely devoid of anything. However, in the eyes of a physicist, nothing can contain a significant amount of information. Physics is a strange subject, right? If you find a phenomenon odd, you are not the only one who thinks so. Don't worry, we are here to explain everything. When we imagine the term nothing, the first thing that comes to mind is an empty room, a region completely devoid of matter, with no single particle in any possible location. This is what physicists refer to as the vacuum state. When there is sufficient nothing, the universe will try to figure out how to fill it, regardless of whether it means making particles from nothing. And there is a chance that everything in the cosmos is just one huge virtual material. The vacuum genesis theory says that the universe started as a significant change inside this nothing that existed before. Even if it has never been confirmed, the concept that you, me, and the entire universe are just a big pile of nothing is appealing to think about. What are your thoughts about this idea? New findings indicate that the universe's growth may be sped up by the fact that most of it is made up of huge, arid regions of nearly nothing, which indicates that all of these huge areas of nothing could describe dark energy. This strange force appears to be tearing the cosmos apart. So, here we are in the desert of nothing. When you look closer across the path from the solar system or the Milky Way galaxy, you see an amazing pattern, the cosmic web, which is the biggest sequence in the universe. At this size, whole galaxies look like tiny dots of brightness. Astronomers see lengthy, flimsy cables of galaxies called filaments, closely packed groups of galaxies known as clusters, and massive, nearly empty spaces in between. The biggest empty spaces might be more than 160 million light-years, whereas the shortest could be 20 million light-years across. Most of the universe is made up of voids, like the holes in a spider web, even though they don't hold nearly any matter. In fact, the only thing bigger than the cosmic void is the cosmic web, which expands from one end of the visible universe to another. You know what? Nothing has great strength. In 1970, scientists discovered the very first cosmic voids, although they've been mostly overlooked. Astrophysicists and scientists have once again concentrated on the brightly illuminated universe regions, like galaxy clusters. In 1990, thanks to these studies, astronomers found a big shock known as dark energy. Dark energy is the term that means the universe seems to be expanding faster than before. This indicates that not only does the universe grow daily, but it grows more rapidly as time goes on. Isn't this something exciting? Astronomers don't know what's causing the universe to expand faster than usual, which may have begun approximately 5 billion years ago. So the word dark energy came about. It's an excellent title for a huge problem in cosmology. What does dark energy have something to do with voids? For one thing, accelerated gross impact aren't experienced within star systems or galaxies, where the gravity of the matter is powerful enough to overpower it totally. For example, our solar system and the Milky Way are not getting more extensive because of dark energy, but due to the voids are just totally vacant. They experience the consequences of dark energy much more strongly. So, it is logical to look into what is causing this rapid growth and where it has the most effect, as well as the latest research studies, which a group of Iranian theoretical physicists led, advances a step deeper in this direction. In their paper, which was posted in July, the authors say that dark energy is not really discovered inside the voids, but that they also prompt it. How do these vast areas of nothingness speed up the universe's growth? The researchers claim that the solution isn't just to examine whether there are cosmic voids and how they change over time. Void doesn't just exist, but similar to all other big things in the cosmos, they started small and grew until they were as big as they are now. Before millions of years, all the matter in the universe was spread equally. There weren't many places with very different amounts of matter. However, over time, places that had a bit more matter than the median began to capture more matter. That area became more appealing with much more matter, which helped it to expand. Over millions of years, galaxies and clusters of stars were formed as matter piled up. the spaces between them got bigger and more empty. Rather than considering it as a passive process, we can perceive the expansion of voids as putting pressure on all over the structures. For instance, as voids expand, the structure of galaxies among them slowly narrow out and start breaking down, enabling voids to join. Within the next few million of years, the voids will break up the cosmos web, separating all the matter into bunches that are hundreds or billions of light years apart of nothingness. Similar to any other origin of matter or energy present in the cosmos, this pressure warps spacetime all around voids. Because of the spacetime deformations, when the voids grow, they force on the galaxy clusters at their edges, which causes them to drift apart even though they are pulled together by gravity. The researchers noted that the way all the big holes in the universe work with each other to break the cosmos web speeds up the expansion of the universe. The power of this estimated growth caused by voids is the same as what we think dark energy is. Astrophysicists will have to do more research to see if this concept is true. For one thing, we have to test more voids to understand how much pressure they add. We also have to know further about dark energy as a whole, particularly if its power has altered in the last few billion years. Even now, it's an interesting idea. Perhaps dark energy isn't induced by a strange power or operation in the universe, but instead is just a side product of how nothingness changes over time. Do you believe sound can transfer through space? We understand that sound requires something to move through, and that something can be solid, fluid, or gas. You can't hear anything in space because there's no air, and sound waves need air. Without air, there are no vibrations. Sound waves cannot be created in any way. It's similar to a whirlpool. As shortly as you describe what it feels like, it really just disappears into the empty space around you. When a sound comes from an origin, it sends out a wave that causes particles in a medium to vibrate and hit one another, making a sound that the ears can hear. In this image, you are able to see sound comes from the source, and the molecules pursue the sound waves. Their molecules vibrate and move in an oscillation because particles in space are far enough apart to oscillate and slide with one another in the right way. Our ears couldn't even hear the sound in space. Before, people thought there was absolutely nothing in space. New research, nevertheless, has shown that space doesn't have as many molecules as we assumed. These particles are also too far apart to be seen. To hinder a sound wave and make a sound wave is two different things. Well, if we can't hear sound in space, that does not mean there's absolutely no sound. This brings us to the end of this video. If you liked this video, please consider subscribing and sharing so we can keep bringing more content like this. Also, let us know your thoughts in the comments below. Thanks for watching. See you next time.